Hello, dear students. I think you remember last meeting time after creating the model of uh, the object. It was the requirement in the last short exam. Uh, one more time saying classwork. Then finally focus your attention to rounding, edge rounding. Uh, Remind you, I said rounded interior edge is called fillet, rounded exterior edge is called round. Why the edges are to be rounded? For interior edges, the answer of this question is to increase the strength of the object, because sharp interior edge, theoretically with zero rounding radius, cause to weakness. Whenever object having a sharp interior edge is loaded, external or internally, in the vicinity of sharp edge within the object, the intermolecular forces per unit of area tends to go to infinity. Intermolecular bonding forces per unit of area within an object is called in general stress. If stress tends to go to infinity, then of course object will be broken, because there is no such a material to resist infinitely large stress value. To be able to prevent weakness, splittings, yes, obey to the recommendation and round the interior edges. How about exterior edges? Why exterior edges are to be rounded? The answer to this question is for preventing possible hand cuttings. If the object is a heavy object relative to the strength of skins of hands, okay, whenever the object is attempt to hold with knife hand along a sharp edge, then the sharp edge may cut the hand. To be able to prevent possible hand cuttings, it is a good design, it's a good practice. We design the exterior edges as rounded. Well, here the created rounded edge you see is a fillet. To be able to create the rounds and fillets, we use in AutoCAD 3D environment of AutoCAD this solid editing tool. It is a multi-optional one. Fillet and edge option is selected to be able to create rounded edges. After starting the process, the first thing to do is that clicked on the down direction key, as it is implied by the tiny little arrow in the first compartment of the train. Clicked on down direction key and then select from the list of options radius option, and then write into this box rounding radius 2 millimeters, 2 centimeters. Well, remember, in creating this model, we changed the unit of measurement from millimeter to centimeter, so this number is in centimeter. Press enter and then indicate the age. For instance, this age. And then press twice enter. It is going to be around. Yes, in AutoCAD. In Inventor, similarly, now open this Inventor file. Remember, uh, this is the model of the object. We created it in Inventor as the content of one of the classworks to see how a model can be created in Inventor, how a hole can be created in Inventor, how an oblique surface can be created. Yes, now say that along this edge, to be able to prevent weakness, rounding is needed along this edge to be able to prevent hand cutting. Rounding is needed. Similarly, in Inventor environment, in Modify panel, find the facility. Although on the button it is written fillet, this tool is to create not only interior rounded edges, but also exterior ones. Not only fillets, but also rounds. Clicked on this button, and then, well, in the dialog box, in Inventor, whenever a process is started, a dialog box appears, not a train, but a dialog box. In the dialog box, into this display, write the rounding radius. Say that in this example, rounding radius is 8 millimeters. In Inventor, since creating this model, we selected ISO template, selected metric unit system. Inventor knows that whatever is written as the size value, it is in millimeter. Yes, just write the number and then indicate the age. Yes, ready. This is ready for being a round. Indicate this age. This is ready for being a fillet. If for all the ages the process is to be applied with the same rounding radius, it is a special case of course, then instead of indicating all the edges one by one and wasting time, use this tool of Inventor, select all fillets, all rounds option. Okay, it is possible. But here in this demo, assume that only for these two edges it is the process to apply. Click on OK. Yes, round, and this is a fillet. Rounded edge, rounded edge. Rounding is the best method for preventing hand cuttings along the exterior edges, but it is relatively expensive process. The other process, it is an alternative to rounding, is chamfering. In Inventor, it is in form of a different button, process button, on which it is written chamfer. Chamfer is an inclined surface. It is created along an exterior edge, sharp edge, to be able to decrease the level of risk for hand cuttings. Well, if the angle between the surfaces, they form an edge, in this example, this surface and that surface, you see intersecting, form this edge. Well, since the surfaces are at a right angle, well, the sharpness angle for the edge is 90 degrees. For a while, imagine, increase the angle, okay, till you reach 180 degrees. If the angle between two surfaces is 180 degrees, this means there is no edge between them, so there will be no risk for hand cutting. Well, from such a limiting case, we see the logic in chamfering process. Why the inclined surface is to be created. Why the inclined surface is created. To be able to increase the sharpness angle. Along the edge, if we create an inclined surface via cutting the material, by the way, cutting material not in cylindrical form to have a round, but in form of a flat surface is a cheaper process. Then, well, creating an inclined surface can decrease the level of hand cutting risk. See how? Clicked on chamfering process button, and in the dialog box, if the chamfer distance is the same over both of the surfaces, this means inclination angle of the chamfer, which is an inclined surface, with respect to one of the surfaces is 45 degrees, then use this option, distance option. Okay, into this box write the chamfer distance. Chamfer distance means the distance between the existing sharp edge and the edge of the chamfer after creation to have. In this example, it is 10. Okay. Before indicating the edge indication button is on. Well, talk about the other chamfering options, distance options. If the second one is selected, over one surface chamfer distance is measured, used as the other parameter, inclination angle of the chamfer is used. Well, if the third option is selected, it is going to be possible to use two different chamfering distances. Over this surface 10, over that surface 2 millimeters, for instance. Now in this example, I'm going to use the same chamfering distances for both of the edges of the chamfer. In other words, chamfering angle gonna be 45 degrees. Okay, the rest is quite easy, indicate the edge. And then say, okay, apply. If you have some other edges to chamfer, continue clicking on apply. But if it is the only or the last surface to chamfer, last edge to chamfer, then click on OK button. Yes, you see, this is not a rounded surface. This is a flat, inclined surface. Well, creating such a inclined surface along the edge, now zoom in and then see the sharpness angle. Between this and that, angle is greater than 90 degrees. Between this and that as well. Not we have, after chamfering, not only one edge, but two edges. But for both of the edges, since the angle, sharpness angle is greater than 90 degrees, the level of hand cutting risk will be less. Okay, in AutoCAD, yes, along this edge, instead of having a round, let us have a chamfer. In AutoCAD, for starting the chamfering process, drop this list in solid editing panel, find fillet edge option. It is a multi-optional facility. Click on the listing arrow and then select chamfer edge option. In AutoCAD, there is only one case to create a chamfer. Chamfering angle is 45 degrees. Click on downward direction key of the keyboard as it is implied by this tiny arrow, and then from the list of options select distance option. Say that chamfering distance in our example is 2.5 centimeters, or say that 2 centimeters. Press enter. Sorry, 2, and then press enter, and then indicate the edge. This is the edge with a click indicate, and then twice clicked on enter key. That is it. This is the inclined surface. If a created inclined surface is for preventing possible hand cuttings, it is called chamfer. By the way, in Turkish jargon, technical jargon, we say pah, and the process name is pah kırmak. Chamfering is in English, pah kırmak is in Turkish. Thank you for watching.